the video on setting up a PBS from SIG with a SIG350 over Ethernet IP to a Toyopuc PC10G. So I've got the sensor plugged into port 1. I've already set up SP1 and SP2, my two set points. Plugged in port 1. In port 2, I've turned the digital outputs on so that I can actually trigger a lamp. You see that lamp come on back there. And I've actually just kind of pushed the data to an HMI as well, just to show live data over IO-Link, how I can show SP1, SP2, and then turn a light on pin 2 and pin 4. So the first thing that we need to do is come into the SIG350. Once you know the IP address, you just type it in. And so I know port 2, I wanted it to be a digital output. I went ahead and turned that on. Now, if you have a PLC connection like I do now, you won't be able to make any changes until you unplug that network connection from the PLC, and then you can change these to digital out and then plug it back in, and it'll save those changes. So once you have that, then we just have to know the PLC mapping. So I've already set this up in my PLC for Ethernet IP connection to my SIG, set up as originator. I came in and I said 192, 168.123. I put my instance ID in, and then my size as far as how many bytes. Since Toyopuc won't take an EDS file, you can get something like Easy EDS and determine how many bytes of data you'll be getting per instance size. This is a free software as well if you really need to dig into the IDD file or the EDS file. So now that you've got that, you can also find the data size in the manual of the SIG350. So if I look here, output size, I can see 275, but since I'm counting the 0 byte, that's actually 276. So that's the PLC mapping of everything and how I got my instance sizes and where the data is going to. So now that we've got that, then you can come see I've just kind of labeled everything. Since the PBS comes over as a float, you can see that here. So if you come to the sensor, you type in a 7-digit part number, you can either just grab this PDF, which will show you the layout of the IODD file, or if you've got an IODD viewer, something similar to what I have here, then it'll come out cleaner as well. But since I just need to know how the data is laid out, I'll come here and it says that my byte 0 through 3 is going to be my pressure, which is in a 32-bit float. And then I've got Q1 or SP1 and SP2 in the 4th byte, and that's coming out of that sensor. So we know how many bytes of data the sensor is spitting out. Then we just have to understand where the data is landing. So if I come to my input assembly here, you'll see that starting on byte 4 is where my IO-Link data starts to come in. So since I'm starting with my PLC at EM0, which you can see here, and I go to EM0L, and I start to monitor, and we said it starts coming in on the 4th byte. So IO-Link data, IO-Link status, it starts on byte 6. So we'll come back here, and I can just verify byte 0, 1, 2, 3, 4, 5, 6. This is where my data start to come in. You see them 32-bit floats. So those 4 bytes are where I'm going to get my pressure reading. But you'll see SP1 and 2 will be down here. As I push it, you'll see those 2 come on. So that's the SP1 and 2 coming in on the 7th byte, or 6, 7, 8, 9, 10. So the 10th byte that are coming in. So Now that we've got that information, we know where it's coming. Since I link data, it has to be byte swapped, and since it's a 32-bit, it has to be byte swapped and word swapped. The easiest way to look at this, we just need to change the order. So you can see I'm taking EM3, the low byte, to 201H, or the high byte, and then so I'm pushing all the data from EM003 low byte to EM004 of the high byte. But I'm starting at 200 and then going to 201. So if you look here, you can see I started 0, 1, 2, 3, and here going to 0, 1, 2, 3. So all I'm doing is rearranging that data so that I get usable data in a pressure range. And then for the SP1 and 2, I did the same thing. I took EM005 that we just looked at, pushed it into 205, and that way I can just get my M bits. So that gives them on or off depending on what the set points are. Then the next thing I wanted to do, since I've already got the data coming in here, as you can see, so the next thing is I want to turn a light on when I hit SP1 or SP2, right? Either on pin 2 or pin 4 of the SIG350. So what I did then is I came down to move the data from where I wanted to go, and then move that into starting at EM100. So if I come back to the manual and I come to output assembly, I can see that my DO status starts here, so I have to do an enable, and then once I enable the pins, then I have to start turning them on and off. So that's what I did, starting at byte 0. So you have an enable bit. So D0 on byte 0 is, or the 0 bit on byte 0 is going to be my enable. And then to turn those on, I'll need to go to, you see, D01. See my coil here, and I'm actually turning that on, right? So number 3, since I want port 2 to be turned on, I go to the third bit, or bit 3. If I wanted to do port 1, then it would be D1-1, or port 3 would be D1-5, right? So it's every other bit for that entire word of data that enables that to come on and turn that light on and off. If I want to do the other pin, so I want to do pin 4, then I would do pretty much the same thing, but since it's port related, then I'd come to the 38th byte. So what I did is I divided that by 2, and I got 19, and I added that to EM 100. But one thing to remember in Toyopuc that messed me up is I forgot that this all counts in hexadecimal. So even though I'm going to 19, I don't need to go to 119. It needs to go to 113 because it is the 38th byte in that array of data, right? So I just take, let's say D400, and I turn my enable on, same thing, and then the next word of data is where the on will be. So I enable it, and then I turn it on. And that's it. That's how you take the PBS, put it to a SIG350, bring the iLink data into Toyopuc PLC, and then from the Toyopuc PLC, send data out to the SIG350 and turn a light on or off on pin 2 or pin 4.